Let's start exploring the VPC objects by looking at projects, networks, and subnetworks.
Projects are the key organizer of infrastructure resources in Google Cloud. A project associates objects and services with billing. Now, it's unique that projects actually contain entire networks. The default quota for each project is 15 networks, but you can simply request additional quota using the Google Cloud Console. These networks can be shared with other projects, or they can be paired with networks in other projects, both of which we will cover later in the Architecting with Google Compute Engine course series. These networks do not have IP ranges, but are simply a construct of all of the individual IP addresses and services within that network. Google Cloud's network are global, spanning all available regions across the world that I showed earlier. So you have one network that literally exists anywhere in the world, Asia, Europe, Americas, all simultaneously. Inside a network, you can segregate your resources with regional subnetworks. I just mentioned there are 3 different types of networks: default, auto, and custom. Let's explore these types of networks in more detail.
Every project is provided with a default VPC network with preset subnets and firewall rules. Specifically, a subnet is allocated for each region with non-overlapping CIDR blocks and firewall rules that allow ingress for traffic for ICMP, RDP, and SSH traffic from anywhere, as well as ingress traffic from within the default network for all protocols and ports. In an auto mode network, one subnet from each region is automatically created within it. The default network is actually an auto mode network. These automatically created subnets use a set of predefined IP ranges with a /20 mask that can be expanded to a /16 mask. All of these subnets fit within the 10.128.0.0/9 CIDR block. Therefore, as new Google Cloud regions become available, new subnets in those regions are automatically added to auto mode networks using the IP range from that block. A custom network mode does not automatically create subnets. This type of network provides you with complete control over its subnets and IP ranges. You decide which subnets to create in the regions you choose using the IP ranges you specify. These IP ranges cannot overlap between subnets of the same network. Now, you can convert an auto mode network to a custom mode network to take advantage of the control that custom mode networks provide. However, this conversion is one way, meaning that custom mode networks cannot be changed to auto mode networks. So carefully review the considerations for auto mode networks to help you decide which type of network meets your needs. On this slide, we have an example of a project that contains 5 networks. All of these networks span multiple regions across the world, as you can see on the right. Each network contains separate virtual machines, A, B, C, and D. Because VMs A and B are in the same network, Network 1, they can communicate using their internal IP addresses, even though they are in different regions. Essentially, your virtual machines, even if they exist in different locations across the world, can take advantage of Google's global fiber network. VMs C and D, however, are not in the same network. Therefore, by default, these VMs must communicate using their external IP addresses, even though they're in the same region. The traffic between VMs C and D isn't actually touching the public internet, but it is going through the Google Edge routers. This has different billing and security ramifications that we'll explore later. Because VM instances within a VPC network can communicate privately on a global scale, a single VPN can securely connect your on-premise network to your Google Cloud network as shown in this diagram. Even though the 2 VM instances are in separate regions, US West 1 and US East 1, they are leveraging Google's private network to communicate between each other and an on-premise network through a VPN gateway. This reduces cost and network management complexity. I mentioned that subnetworks work on a regional scale. Because a region contains several zones, subnetworks can cross zones. This slide has a region, region 1, with 2 zones, Zone A and Zone B. Subnetworks can extend across these zones within the same region, such as subnet 1. The subnet is simply an IP address range, and you can use IP addresses within that range. Notice that the first and second addresses in the range, .0 and .1, are reserved for the network and the subnet's gateway, respectively. This makes the first and second available addresses, .2 and .3, which are assigned to the VM instances. Other reserved addresses in every subnet are the second to last address in the range and the last address, which are reserved as the broadcast address. To summarize, every subnet has 4 reserved IP addresses in its primary IP range. Now, even though the 2 virtual machines in this example are in different zones, they still communicate to each other using the same subnet IP address. This means that a single firewall rule can be applied to both VMs even though they're in different zones. Speaking of IP addresses of a subnet, Google Cloud VPCs let you increase the IP address space of any subnet without any workload shutdown or downtime. This diagram illustrates a network with subnets that have different subnet masks, allowing for more instances in some subnets than others. This gives you the flexibility and growth options that meet your needs, but there are some things to remember. The new subnet mask must not overlap with other subnets in the same VPC network in any region. Each IP range for all subnets in a VPC network must be a unique, valid CIDR block. Also, the new subnet IP ranges are regional internal IP addresses and have to fall within valid IP ranges. Subnet ranges cannot match, be narrower, or be broader than a restricted range. Subnet ranges cannot span a valid RFC range and a privately used public IP address range. Subnet ranges cannot span multiple RFC ranges. The new network range must be larger than the original, which means the prefix length value must be a smaller number. In other words, you cannot undo an expansion. Now, auto mode subnets start with a /20 IP range. They can be expanded to a /16 IP range, but no larger. Alternatively, you can convert the auto mode subnetwork to a custom mode subnetwork to increase the IP range further. Also, avoid creating large subnets. Overly large subnets are more likely to cause CIDR range collisions when using multiple network interfaces and VPC network peering, or when configuring a VPN or other connections to an on-premises network. Therefore, do not scale your subnet beyond what you actually need.